Right, in this video, I'm going to demonstrate to you creating a smart contract using Helios, off-chain plus on-chain in a very quick way. I have
Okay.
already created running smart contract, but when I show you, you are going to see it's one page and everything works. Let me start by showing you the smart contract.
Okay. Yes, sir.
Right, we've got this smart contract creates NFT. The on-chain part is this one here. Do you see this on-chain part?
Yes, I see
It's
it.
just a couple of lines, not even a lot of it.
It's just
It's just
telling.
one function.
Mm,
These are parameters you are going to give to the function. But the function is just having one parameter, which is a script context. It's a function, there it is,
mm-hmm.
pool. And then from there, you see here, you create a minting policy hash. This is why I've asked you questions. Do you know what is an MPH? Because this creates it.
Okay. So the
And then
minting policy hash.
here you see you create an asset class. So you need to know what is an asset class.
Mm-hmm.
Yeah,
And
because
then,
an asset class requires a token name in a encoded UTF-8 and a minting policy hash.
okay.
Yeah, and then down here you are saying a transaction minted, and you assign this to this value. You need to know what is a value data type, and here is the logic here, which only says that only one asset type, which is an NFT one, has been minted. All right. Now let's go back to the other part. That is the on-chain part. That one is created using Helios. You can even test it on the playground.
Okay.
So now things are chained together here. It's all it's one page, not even 400. It's about 350 lines. All right. These are Helios classes, TypeScript classes, asset class, the address class, byte, array data, SIP30 handle, SIP30 wallet, const data for the redeemer, hex to bytes, because it has to convert everything to binary. Then the network params for connecting to the blockchain via block frost. Here is the value. Value is a data type, is a class. You can see
Okay.
there is a class which you can see
Okay.
where it comes from. You have that. And then you've got the TX output. Right, that's another class.
Okay.
And then you've got the TX for transaction, another TypeScript class. So another class. So basically for me, I would say somebody must just go to Helios, learn how these classes are created and the methods that they do have. Because the rest down here, taking those classes and calling the methods.
Okay.
Yes, that is all what it does. Right, if we go here, this one, when you connect a wallet to the browser, then this interface window has got Cardano, and it will identify the Cardano wallet. So that one is always there, you just copy paste there. Right, these are variables that we need. This one is just use state. You need to know React or Next.js use state, this use state, use effect. So basically, learning TypeScript is the beginning. You need to learn React after TypeScript.
Okay.
And then next, you learn Next.js. I always say start with JavaScript, learn TypeScript, learn React, then learn Next.js.
Okay.
Yes. Right. So all these are different ways of creating variables from React. Then we have got functions that must run when a page is being loaded. So which wallet is selected, wallet is enabled, check the browser, wallet API. So you run those ones when the page loads. So these are helper functions that are being called by those, what you call page cycling methods.
Okay.
These one, handle wallet, select, check if wallet found,
And enable.
enable wallet, and even get balance. They are called by these life cycling methods. See here, check wallet found. It is a helper method, which is this one down here. But
Mm-hmm.
it must run when a page is what? Being mounted, being loaded. Same with this one here. You see you are calling enable wallet helper function. This enable wallet helper function, it is this one here. These 1, 2, 3, 4 are helper functions.
Okay.
Right, then this process is the one that is a function for minting an NFT onto a wallet.
All right.
I'll go through the steps there very quickly. But what I want to show you here first is the front end. Basically, this is the front end with the controls that you see there. That front end is this, what you see here.
Okay.
Hlios NFT smart contract demo, select wallet. So now you need to know HTML. Then after knowing HTML, then you need to know React, JSX, the form of components React uses on the browser. But basically, with Next.js, you can even use the normal HTML DOM elements that we have.
Okay.
They will still work. That is why even here, we have got normal divs. You just look here. We have a normal div with a class style.
Mm-hmm.
That is this part of Helios NFT smart contract. And then you have got the main element. You see here, the main, it is JSX. That is the React.
Okay.
And then the div, you know the div. The very fact that this thing is on a JavaScript, you can see return this
Mm-hmm.
JSX. Yes. So it is the JavaScript that is going to do the processing of the DOM element. Normally, in a normal HTML page, this would be index.html, and these HTML text would be on their own.
Mm-hmm.
Right, let us test it. Then let me explain the actual minting of the token so that you see the code is not a lot and it's easy to follow. Right, we start by enabling the wallet. This happens when I click the button Mint NFT. So before I click the button Mint NFT, the first thing is when this loads, I have to select a wallet.
Yes.
So on my browser extension there, I've got Nami wallet. I've got an NFT. Right, you can see here on this NFT account with 61 test header, I don't have an NFT. So I select the NAMI.
Mm-hmm.
Then here I need to put an address where the NFT is going to be sent to. So I can use the same account and then get this as a receiving address. So I can use another address, another wallet. So in this case, I'm trying to mint an NFT from the same wallet that is connected. So I can give it a name. This one I'll call it Billie. Test NFT. That is the name of the NFT.
Mm-hmm.
Let me say Billie and Ben. NFT. Right. Minting lesson. Then here we need to enter an image. So we can get a Coxygen image online. I'll just open the coxygen.live.co live and then get the you see this logo.
Yes.
So I get the URL, copy the image address, which is this one here. This goes to that image address. I'm going to use that for, remember, as an icon for our NFT.
Mm-hmm.
So that when the NFT appears here
It appears with an image.
on this one under assets, we must see that image there.
Okay.
So basically I've supplied the parameters needed by the smart contract when it is minting. Right, let's mint. There we go. Gonna spend 0.27 fees. And look, I am creating one asset. Its name is what? Billie and Ben testing NFT 1. Right, details are here. You see this part here, it is the information about that NFT. It is a 721 Cardano standard.
Okay.
And then there is the name, you see Billie and Ben. This is the MPH, the minting policy hash. It is a hash of this data here, the minting policy. The minting policy, what is the name of the NFT? It is this one. And in this case, it is 1. We've got a 1. The description is there. Here is the image URL I showed you. There is the name. Right.
So,
Let
so
us,
now
yeah,
this NFT is now this is the information which will be on the blockchain.
on the blockchain.
Ah.
So now I'm signing it to send it to the blockchain via this smart contract with Helios. Success. How do you know success? Do you see here? Transaction success. And then we've got a transaction ID on blockchain now. So here now, when I click here, it actually opens the Explorer, and it took 7 seconds and it was immediately minted. Right. Let us look at it here. Took 7 seconds. That was pretty fast. Let's see here this side. Right. We've got 4 assets and NFT 1. Look at this.
Blockchain is so interesting. Wow.
Very interesting. And there it is. Look at this. There is the policy. I told you the NFT policy, CFA9. That is the one that I was showing you. And then there is the asset there. Now, something interesting now. I can send it to you. I've created a nice Coxygen NFT, and I can send it to you from here. That's pretty interesting because I can send it here. It's 1. I could have minted 10 different tokens or different assets. All right, this Explorer explains what happened 7 minutes ago. This is the transaction hash, transaction ID. There were 2 inputs. There was a 5 header from the same address. You see, this was the address, wallet address that you saw there.
Yeah, on NAMI, yes.
On NAMI. And then this, on this also, we took this 1.5 and the 5. And then there were already some vesting keys, some tokens there. The outputs, what you see on the right here is the outputs. We've got inputs, then we've got outputs. Outputs, we've got 2.72 that went back to that same address. And then 2A was sent to this same address. And then down here, we've got the NFT, Billie and Ben testing NFT. And then there was also some fees, 1.5. There is also some money there. You can see where it says fees, coffee, 0.28 fees were used. And then here you see a smart contract. This type of a transaction is a Cardano smart contract. And then this is the fee in dollars. You see, this is the dollar version of this fee.
Okay, yes.
So we go to the next step. Remember, this step was content. The next step is contracts. So we look at that smart contract here. So we had a redeemer, but that redeemer was not used. Was not used. I'll show you where we had these inputs, outputs, and the redeemer, where we bungled the transaction process. This version, Bluetooth version 2, you see this script hash. This is the smart contract, which is this one here, but it is in a binary format.
Okay.
Let's go back. You see the smart contract. This is the smart contract in a Helios language, which is TypeScript-like. And then what you see here on the Explorer, where is the Explorer? Here. This is the SIBO. SIBO stands for Concise Binary Object Representation. It's a binary representation of the smart contract. This is what is on chain. So on chain, it is not in a Hlios language. It is in a binary format.
Sure.
So let's go to the next one here, the collateral. 5 ADA was the collateral. There it is. Where did I set the collateral? The collateral, when you create a wallet, you must send some funds onto the wallet account and then set a collateral down here. There is the 5 ADA. Just set it. If you don't set it, it is a requirement so that if this thing fails due to some people spamming, that collateral is forfeited. But when everything runs successfully, that collateral is returned back. That is why you see it was never used, but it was needed for the transaction to prevent spammers, network spammers. Then mint, this is the NFT that was minted. You can see there is the NFT asset, and then there is the policy of the NFT. How many? One. Right, we can click here, but before I click this side, we can click here. We can go to the metadata. Right. You can see here it says the message contains user-generated unmoderated content. Would you like to view it? Yes. Then our metadata. It is 721.
Yes.
And then the script. Remember now we have got the contract. Whenever you run on chain, you've got the validator script, the Bluetooth validator script. So there we go. It is Bluetooth version 2 script. Well, I have never checked. There it is, the details about Bluetooth version 2, mint 1 KB, bytes. It can show you the bytes. And then some of this information is very difficult to understand. Okay.
So every smart contract is what you call, it's sort of like taken through the Bluetooth.
Yes. Bluetooth is the virtual machine. Bluetooth virtual, it's a virtual machine. Like Ethereum, you've got Ethereum virtual machine. On Cardano, you've got Bluetooth. It is the virtual machine that is the one that runs on blockchain, Cardano blockchain ledger. Because you've got a Cardano blockchain ledger. Then for it to have these NFTs assets, you need a virtual machine, be it a Ethereum virtual machine. But in this case, it is the Bluetooth. There is another lesson which we are going to do on Bluetooth core architecture.
Okay.
Then you will understand the validator process, validation process, validator script, generating a script hash. It's very small code, but it requires a lot of, it has a lot of logic and it requires a lot of concentration. So there we are, 26 past 10, we have created, tested, deployed a smart contract on chain, but this time we're using pre-production testnet. Any question?
No questions. I'm just fascinated.
Very fascinating.
Very fascinated.
Right. When you have done this for me, then you are going to do two things for me. One, you are going to create a user manual. You see, I was visually or audio explaining to you this whole process, different parts of this smart contract, Helios NFT smart contract demo.
Mm-hmm.
I want also a PDF user manual you will give to somebody. He can read and see the bits and pieces of the code, what it is for, where it works. It must accompany this source code. The second one is a video. I'm already recording a video. So it's a matter of you now create a video demonstrating typing step by step the whole smart contract from the beginning to the end, so that you show a new person how to create and test it. So that is the most important thing. Right. Now you will understand this part. When I click process, the minting process begins here. It requires first you enable the wallet. That part is done. You've chosen NAMI wallet. And then now we need some variables, minimum order, then fee, and then you need a change amount, then you need a minimum order value. Now, remember, you've got a number here, minimum order, but on chain, it won't know what is this. So you need to convert this to big int. Once it has been converted to big int, which is I can say a Bluetooth code data type, now you need to cast it into a value. Remember, the value now is the same money amount, but now it is represented as follows. Either it's loveless or it's an asset. You will know what is an asset later. Remember, asset has got a token name and a quantity. Right.
Okay. Mm-hmm.
The moment it doesn't have a token name, then it is loveless if it is less than 1 million. The moment it is 1 million, that's one order. So Cardano is so smart because ADA and your token, the token that we have, are both native. They are running on the same blockchain. That is why transaction fees are very, very, very low. Right. Let's go to this next step here. You need a UTXO from the wallet. Why do you need a UTXO? Because it is a U unspent. You need to spend it and take whatever value it is, pay some fees, and then create new outputs. So here, this is unspent transaction. Then from there, you are going to have inputs. This is the output which will come as an input. Need a change address. So this wallet helper, it is in short, it is that class that has got a function or a property called change address. So it is that class that will take the wallet, use this property change address, and then go to NAMI and select an address that is going to receive the change. Right now, we are building the transaction now. That is the most important part. You need to instantiate a class called TX. This is a TX TypeScript transaction builder class on Helios.
Mm-hmm.
Right. It has got a method called add inputs. That is why we need inputs. We go to the UTXO and we pick the first one. It's an array of UTXOs. So we pick the first one. So that is the first thing that we add to the transaction builder. Then the second thing that we do add to the transaction builder is the script. Remember, I showed you script, which was Bluetooth version 2. So
Yes.
that
Yes.
is the second thing that you add to the transaction builder process. But before you add it, remember, this script takes in a UPLC program. UPLC stands for Untyped Bluetooth Core Program, which in short, it is that smart contract in Helios that I showed you.
Mm-hmm. That is on chain. Yes.
Yeah, that is basically that smart contract on Helios that I showed you, this one here, which I clicked here. It is that program. When it says program, you will see it takes the following inputs. It is this program that you see. If you want to see it properly here, I have said NFT new program. But if you look at that program here, and I go to the top, you are going to see that this program, you see, it is that NFT dot Helios, which is HL, on the contracts here, which is on the contract, which
Mm-hmm.
is the one that I've just shown you.
Mm-hmm.
Yeah, it is simply that. And then here we are giving it the parameters it needs for it, like the token name, Billie and Ben. And then here we need to give it a transaction index and a hex for it to work. So that is number 2. Remember tx.add inputs. This is the Helio function from this transaction class. Number 2, attach scripts. There are about 8 of them. So 2 attach scripts. And the next one is mint tokens. So that is number 3, mint token. This mint token function takes 3 parameters. It takes in the minting policy hash, MPH, and the tokens, and the redeemer. In this case, I told you the redeemer, when I showed you, it said 0 because it is 0. We are not using it now, but later on, we are going to know the parameters of the validator, which is Bluetooth validator, which are
Okay.
D2, redeemer, and script context. Right. So let's go to number 4. That is add outputs. Remember, add inputs, attach script, mint tokens, add outputs. This explains to you EUTXO, unextended unspent transaction output. So that is the output. We need to add a new output with an address. Why? Because Bluetooth is gonna ban the input UTXO. It's gonna be spent. That is the S. Is spent, destroyed. And then new ones are going to be created. Those are the outputs. So where are they going to reside? In this case, they will reside on this address, which happens to be the same address that I did supply. You can see here the value, the loveless, and the asset, which is our policy hash, which is our token basically here. So this wallet address is gonna have this loveless, which probably, yeah, I showed you minimum utter value plus is gonna have that NFT, and it's going to be an output now sitting again back on the same address that we used. If I had used another address, it was going to go to that new address. See, for you to understand Bluetooth, you need to understand UTXO. UTXO are accounts with funds which will be needed for new UTXOs to be created. So one UTXO is going to be destroyed, its value then transferred. But to where? New UTXOs are going to be created that are going to hold the change and the value and the NFT, those assets. And then they will either belong to a specific new wallet address or to the same wallet address specified here. Once you have understood that, then we are done. Then the next fifth one is add metadata. Yeah, I showed you 721 metadata, which is CIP68 standard. From here, this is where we say finalize. That is number 6 or number 5. Finalize. Finalize basically here, it is connecting to the blockchain via block frost. Or yes, via block frost. And then here, it takes the change address, then the UTXO. See here, I'm giving it UTXO1 because UTXO0 is being destroyed when it is an input, add input. Here, you look at add inputs. The inputs will be destroyed, outputs will be created. So that is why here we have 1, not 0. Because you put 0, that one is going to be destroyed. Right, from finalized now, basically what is left is we need signatures. When I'm putting that password, actually my wallet is signing that transaction. If finalize succeeds, this is where a lot of failure happens. There are some inputs that are incorrectly given or inputs that don't have funds. So finalize fails. It is a checkpoint to make sure that before this thing goes to blockchain, everything is fine. Everything is fine, then it cannot go to blockchain until it is signed.
Signature.
This is now this function add signatures. Remember, it can be signed by more than one. It is a multi-signature. Or it can be signed by one person. In this case, it is me who signed it. And then the last one is the submit the transaction to the blockchain. I want you to see the submit TX is not a function of the TX. It is a function of the wallet API. So you mustn't be confused there. Even the signatures, remember the signatures, when you are getting signatures from the TX, sign TX is from wallet API.
Okay.
Right, sorry, my dog is making noise, but just ignore. And this part is the one that runs and show us a TX hash, which is the one that I clicked. After clicking, it opened the Explorer.
Oh,
Let's count the steps of the transaction from add inputs
final.
to submit TX. Right, so I'm gonna show you here one. So let me just edit here so that you go. Add inputs. This is the function of the TX. That is number one. Number two, attach script. The code above here, from here to here, it is preparing the input, which is the UPLC program here. Then this becomes number two method of the TX. And then the next method, because in this case, it is mint tokens. And we supply those three parameters. And then we go to the next one, which is add outputs. Maybe you can ask me, does the order matter which one I put first? Order doesn't matter. As long as everything is there, it will run. Add outputs. See, this is number 4. And then we go to the next one, which is add metadata, which is the standard SIP68. Bitcoin doesn't have this. That is why Bitcoin doesn't have what? Smart contracts. Ethereum is using something else, which is a lot of insecure and not as efficient as this one. And the finalize 246. You see the finalize. But remember here, you are going to call the sign, the signatures. And then we come here now, we call the submit. I told you there are 8 transaction building steps. You can use this Cardano CLI, it will still work. You can use Haskell, it will still work. You can use ICANN, you will still do these 8. You'll add inputs, you'll attach the script, which means you have to prepare that UPLC program, data type. That script must be converted to UPLC program. But you have to add call mint tokens. There may be different functions in different languages. Maybe ICANN won't call it mint tokens. They might not call it add inputs. They might just call it input, but it will still be inputs, outputs, a script program, and then metadata, CIP 1668. Then here finalize is always you build the unsigned transaction. And then here you get the signatures, you sign. So here it produces a built transaction, but that has no signatures. And here it takes that and it adds the signatures. When I sign on my wallet, that signature gets added onto a list of signatures that signed the smart contract. And then from there, this is submitted to the blockchain. The finalize also helps to determine the transaction fees, or if this thing is gonna fail. It fails, then you don't lose your money. In Ethereum, it fails, you lose your money if any transaction fails.
Mm-hmm.
Here it fails, you don't lose your money. So it is called deterministic smart contract. Any question? For me, I can always say, no, this, they will always be like this. Maybe on the later Bluetooth versions, they are going to be shorter. And then the second thing that is for me most important is the TypeScript or the Bluetooth types or classes, these ones.
Okay.
The assets, the address, all these CIP angle, this thing here. Basically, if you know this and you know TypeScript, Next.js, whatever,
Mm-hmm.
then you have got the foundation. You have said one. Otherwise, you are at zero, step zero.
Okay.
But now at step one.
Okay.
Then what will be the next step two? The next step two now is to create different versions of the smart contracts. Now here you design another version of the smart contract, this time with a datum and then with a redeemer, and then you put the logic for validation here. That is the most exciting part. And then because now you know how to supply parameters, Helios makes it very easy. Because now here you supply the parameters, you see. And this thing is built on fly. The on-chain code is compiled, SIPO is immediately linked to the parameters, and then everything is happening on one page. Very quick, very short. This took a long time because I was explaining, because I really need you to understand this smart contract using Helios. I'm gonna try to do a similar smart contract using other languages. But why I like Helios? Helios is JavaScript. It's on a browser. One page, you do everything. The only page that we called separately was this contract NFT, of which you can even put it here. So for demonstrating smart contract creation, design, deployment, off-chain, on-chain, Helios is the best language ever so far. I have been with the Haskell.
Mm-hmm.
I have used the command line. The most difficult of them all, but which is a good start, is the CLI. Use the CLI to deploy your smart contract. That one is the manual process and the scripts. In Haskell, also has got a steep learning curve. But when you get to IK and you get to mesh, you get to this one, Helios. ICANN uses Lucid front end. Lucid is more like a UI. ICANN supplies the on-chain backend. They work together. It's more like you'll be using two languages, from what I have seen with ICANN,
Mm-hmm.
but it's the most popular so far.
It's icon.
ICANN, yes. Then we have got other one like Mesh. Mesh is from Mesh, and this one is very close to each other because Mesh, they have created React components that are tied together with smart contract, with Cardano smart contracts. All right, I am done. Any question from your side?
No question so far, sir. I'm still trying to piece it together.
How did you find it? Give me your honest feedback. How did you find this training that I have given you?
Like for me, honestly, I like it because I'm like very, very interested in learning these things. Even though like some of the terminology is new, but the way you explained it, sir, it's like you're taking it step by step and telling
Yes,
me like what this code is doing. So
yes.
like I like that. That is very good.
Definitely, oxygen ought to be like this. Then the next part is we need to manually get you coding.
Yes, sir.
When we walk through, you code, you stumble upon bugs here, and then we stop there. We debug up until you have got it running like the one that I showed you.
Yeah, I think the coding part will be fun also.
All right. Oxygen is the best gift for Cardano developers, especially new ones.
Yes, yes. Now I see the value. I see why people were very excited about this
Yes,
proposal, sir.
definitely.
Mm.
All right, let's stop here. I want to run somewhere.
Okay, sir. No, thank you so much.
Thank you very much. Bye.
Okay, have a great day.